This is a really good question about sampling distributions, and I've had a few questions about it in class, so I wanted an opportunity to go over it with you. All right, so in this case, we're told that the superintendent of a large school district wants to know a proportion of middle school students in the district planning to attend a four-year college or a university. Suppose that 80%, whoops, didn't want to use that. Let's try that again. Bingo, all right. 80% of all middle school students in the district are planning to attend a four-year college or a university. This is a rare case where we are given the parameter going into this. Now, the superintendent wants to know this. He doesn't know this. So it is a parameter that we know, but whoever's doing the sample doesn't know. So we're asked, what is the probability that a simple random sample of a size of 125 will give a result within 7 percentage points of the true value? Okay, so you'll notice I already started building a normal distribution here. Reason is, I know my sampling distribution's normal because, first of all, it's based on an SRS. I know that I have a sample size that is 125. Should be, it's a large school district that's going to be less than 10% of the population. And then opportunity for 10 successes, 10 failures. So let's see, if you really want to get down to it, if you go into it not knowing, then 50% of 125, because you always want to assume 50% if you don't know. 50% of 125 is definitely going to be greater than 10, and that would be okay on both counts. So we're okay in the large counts condition. We can assume that this distribution would be normal. So I know what my mean would be. It would be my parameter right here. Now I have to figure out my standard deviation. And you notice I have the formula here for a standard deviation of a sampling distribution based on proportions. I take the probability of success, or that statistic, probability of failure, all over size of your sample, and then find the square root. So you'll notice I already plugged it into the formula here. Now I just need a calculator because I cannot do this one in my head. Maybe you've already gotten this value. Maybe I should have done this already. Whoops. 0.8 times 0.2 divided by square root. Okay, so I get about 0.35. Actually, it's like 0.36. It's like 0.357, so I'll go 0.36. So that means if I were to draw this normal distribution, I'll go out two standard deviations. So, and actually that's 0.36. That's a good catch. I'm glad I caught that. This is 0.036. Okay. So that would go 0.836. Go up again, 0.872. And all I'm doing is I'm adding the standard deviations as I go, and now I'm going to subtract them. 0.0764. And then subtract the standard deviation again, and I get 0.728. So we're looking, what's the probability that a simple random sample will give me a result within 7 percentage points of the true value? Now remember, within a sampling distribution, this represents all my possible statistics here based on that population. So I can imagine a bunch of p-hats in here. I'm not going to draw all of them, but you get the idea. These would be the statistics I'd get from any random sample that I would do of 125 based on this population. There are a lot of possible statistics I could get. Now it's saying within specifically 7 percentage points of the true value. So if I take 0.80, I subtract that 7%, that'll give me 73%. If I take that 0.80 and I add 7%, that would give me 0.87. So I'm looking at the probability that I'm going to find statistics kind of in this ballpark. And I'll shade it in here. So somewhere in here. So based on what I know about normal distributions, since it's almost two standard deviations out, I can be pretty confident that my answer should probably be in the ballpark of about 95%. But just to be safe, I'm going to use norm CDF on my calculator. I recommend you do the same thing. So I'm going to plug in 0.73. So that's my lower. My upper is 0.87. My mean is 0.80. and my standard deviation is 0.036. Notice how I'm labeling everything. So I'm going to use my calculator function. I recommend you do the same, and we'll see what we get. Of course, I have the older fashioned ones here. I have to enter in things with commas. A lot of you have the labels that are pretty helpful. Cool. And my answer was really close to 95%. As a matter of fact, it was 0.948. So what that tells me is that the statistics that are going to be either 7 points lower than the actual mean or 7 points higher than the actual mean, I'm going to be looking at about 95% of my statistics that fall in there. So again, the key here was recognize that you got a sampling distribution that is normal based on proportions. You have a parameter that exists, but whoever is doing the sample doesn't know that parameter. So they do this sample size, we checked our conditions quick, and then we figured out our standard deviation based on the information we have here, created the sampling distribution for those possible statistics, and then we found the percentage of all the statistics that fall within the range that we're looking for. Hopefully this helps you with this problem, and hopefully helps you with further problems down the road with sampling distributions.